In November 2025, NVIDIA's market capitalization reached $5 trillion, making it the most valuable private company in history. To put this in perspective, NVIDIA is worth more than the GDP of the United Kingdom, France, or even Germany. But behind this extraordinary valuation lies a story about supply chain management under pressure, about how one company navigates manufacturing bottlenecks, geopolitical tensions, and technological constraints that threaten to limit its growth.
NVIDIA operates what's called a fabless business model. They don't manufacture their own chips. Instead, they depend entirely on Taiwan Semiconductor Manufacturing Company, or TSMC, to produce their processors. This partnership, while technologically successful, creates a critical single point of failure in their supply chain. The challenge centers on advanced packaging technology. NVIDIA's latest generation chips, called Blackwell, use an extraordinarily complex manufacturing process called chip-on-wafer-on-substrate, or CoWoS. This isn't simply printing circuits on silicon. Multiple processor dies must be bonded together with microscopic precision, connected through advanced interposers, and packaged as a single functional unit. The problem? TSMC's CoWoS advanced packaging capacity is severely limited. Think of it like this. You might have unlimited ability to manufacture car parts, but if you only have one assembly line capable of putting those parts together into a finished vehicle, that single assembly line becomes your bottleneck. NVIDIA secured over 70% of TSMC's entire advanced packaging capacity for 2025. But even this extraordinary allocation cannot meet global demand.
In August 2024, NVIDIA discovered a critical design flaw in the Blackwell GPU architecture. CEO Jensen Huang admitted publicly it was 100% NVIDIA's fault. The defect didn't make chips completely non-functional, but it dramatically reduced manufacturing yields that measure what percentage of chips coming off the production line actually work properly. Lower yields mean more wasted silicon, higher costs per functional chip, and significant delays. To resolve this defect, NVIDIA and TSMC had to execute what's called a mask change. In semiconductor manufacturing, masks are the intricate blueprints that guide how circuits are etched onto silicon. Changing these masks involves hundreds of manufacturing steps, each requiring precisely calibrated equipment. The entire process takes months to complete and validate. This single design flaw delayed Blackwell shipments by approximately 3 months, affecting major customers, including Google, Microsoft, Meta, and Amazon. For a company with billions of dollars in backlogged orders, these delays created massive supply chain pressure. Beyond manufacturing, NVIDIA faces an increasingly complex geopolitical landscape that directly impacts their supply chain operations. The United States government has implemented strict export controls on advanced AI chips, particularly targeting sales to China. These aren't minor regulatory inconveniences. They fundamentally reshape market access and supply chain planning. NVIDIA initially responded by creating modified versions of their chips, the A800 and H800, with reduced capabilities that technically complied with export restrictions. But U.S. authorities quickly closed this loophole, banning these modified chips as well. China represents a potential $50 billion market for NVIDIA. Losing access to this market doesn't just reduce revenue, it creates strategic vulnerabilities. Chinese companies, unable to purchase NVIDIA products, accelerate development of domestic alternatives. Huawei's Ascend processors, while currently less capable than NVIDIA's offerings, improve rapidly when NVIDIA chips remain unavailable. Meanwhile, China has responded with its own restrictions. In 2025, China banned NVIDIA chips from government and critical infrastructure sectors. Chinese customs increased inspections of NVIDIA shipments, and China tightened export controls on rare earth materials essential to semiconductor production materials NVIDIA supply chain depends upon. Taiwan, where TSMC manufactures virtually all of company's advanced chips, sits at the center of US-China tensions. Any disruption to Taiwan's stability directly threatens NVIDIA's entire production capacity. This geopolitical risk isn't theoretical. It's a supply chain vulnerability that NVIDIA's leadership must continuously manage. Manufacturing and geopolitical pressures have created a fundamental supply-demand crisis. In the November 2024 earnings call, the company projected that demand would exceed supply for several quarters into fiscal year 2026. CEO Jensen Huang noted that the laws of physics limit how quickly production can scale. This imbalance triggers multiple supply chain challenges. First, customers face prolonged lead times for chip shipments. Organizations planning to build AI infrastructure cannot reliably predict when equipment will arrive. This uncertainty forces them to create contingency plans, delay projects, or, critically for the vendor, consider alternative suppliers. Second, scarcity empowers rivals. AMD and Intel, though generally behind in AI chip performance, gain openings simply by having available capacity. Some buyers, unable to wait months for preferred accelerators, switch to these alternatives. Each such loss risks long-term market share erosion. Third, allocation choices become strategic dilemmas. When output cannot meet demand, you must decide what to produce and who gets priority. Should the firm focus on its highest margin data center products, or maintain consumer graphics card production to preserve brand loyalty and market presence? The design flaw in the Blackwell architecture had a direct impact on the company's financial performance. When production yields fall, the cost per usable chip rises sharply. More silicon wafers are consumed, greater manufacturing capacity is lost on defective units, and additional quality control resources become necessary. The firm cautioned investors that gross margins would likely drop into the low 70% range, below historical levels. This translates to hundreds of millions of dollars in reduced profitability until the underlying production problems are fully resolved. For an organization long known for peak operational efficiency, such margin pressure is considerable. At the same time, the shift from CoWoS-S to the newer CoWoS-L packaging technology demands significant capital investment. TSMC must install upgraded equipment, retrain its workforce, and validate new manufacturing procedures. Throughout this transition, the company needs to coordinate overlapping production streams across different generations, continuing to produce Hopper chips with CoWoS-S while gradually migrating Blackwell to CoWoS-L. Perhaps the most strategically complex issue lies in capacity allocation. The company has secured more than 70% of TSMC's advanced packaging capability, an extraordinary share that highlights both its significance to the manufacturer and the fierce competition for this limited resource. However, such concentration also creates dependencies. The organization must carefully balance its relationship with TSMC, negotiating for additional capacity while recognizing TSMC's obligations to other clients. It must decide how to distribute limited manufacturing slots among different product lines and navigate geopolitical regulations that restrict where specific chips can be sold. Meanwhile, Chinese firms, anticipating ongoing shortages, are rapidly developing their own GPU technologies to lessen reliance on American suppliers. As a result, the very supply constraints faced today are helping to cultivate competitors for the future. One of the company's first major steps was redefining its relationship with TSMC, from a standard contract manufacturing setup into a deep, long-term strategic alliance. When the Blackwell design flaw surfaced, this collaboration proved essential. Instead of merely notifying the firm and waiting for instructions, engineers from both sides worked closely to implement and validate the necessary mask change. Jensen Huang praised TSMC's response, describing it as operating at an incredible pace to restore production. This kind of coordination is built on trust, shared technical knowledge, and common strategic goals. The organization has also invested in improving TSMC's efficiency by deploying AI-driven planning systems tailored to semiconductor supply chain optimization. These tools evaluate thousands of production scenarios simultaneously, pinpoint potential bottlenecks before they arise, and adjust manufacturing schedules in real time. This effort creates a compelling strategic reversal. The company is using its own artificial intelligence, technology that fuels global demand and strain, to make its production network more intelligent and responsive. In doing so, it not only enhances TSMC's operational capabilities, but also strengthens its own position as the chipmaker's most valuable partner. Understanding that the real bottleneck stemmed not only from limited output, but also from production efficiency, the company accelerated its move from CoWoS-S to the more advanced CoWoS-L packaging technology. CoWoS-L introduces a local silicon interconnect and a reconstituted interposer structure that reduces yield issues found in earlier generations. More importantly, it is inherently scalable, enabling TSMC to expand capacity at a much faster rate than before. According to Jensen Huang, total advanced packaging capacity has increased roughly fourfold within just 2 years, thanks in part to this technological shift. However, the transition brings its own operational complexity. The company must sustain parallel production for multiple technology generations, retrain staff to handle updated procedures, and coordinate logistics carefully to transition capacity without interrupting existing customer deliveries. This deliberate, phased approach exemplifies mature supply chain management. Instead of abruptly discontinuing older products and leaving clients unsupported, the firm continues overlapping production while gradually migrating toward the more efficient and scalable process. The outcomes of the company's supply chain management efforts have been clearly positive. Despite the initial setbacks caused by the Blackwell design flaw, production has scaled rapidly, with several $billion in Blackwell-related revenue shipped each quarter, a remarkable accomplishment, given the technical complexity and earlier delays. Manufacturing yields have now returned to strong levels as the transition to CoWoS-L technology has stabilized. Clients who once faced months-long waits are receiving deliveries much closer to schedule, and the organization has successfully maintained its position as a technological leader throughout the process. The company's supply chain journey offers valuable insights that reach far beyond the semiconductor industry. First, true strategic partnerships go well beyond basic vendor relationships. Deep collaboration with essential suppliers, as seen in the company's partnership with TSMC, enables faster problem-solving and joint innovation. When difficulties arise, partners who understand your priorities and share in your success can respond far more effectively than distant transactional vendors. Second, openness about supply chain challenges can actually strengthen stakeholder confidence. By frankly acknowledging that the Blackwell defect was its own error and communicating transparent timelines for resolution, the company reinforced trust among both investors and customers, demonstrating managerial competence and accountability. Third, sustained investment in supply chain intelligence and AI-driven forecasting translates into a measurable competitive edge. The ability to predict disruptions before they emerge, adjust inventory in real time, and react swiftly to market changes provides a distinct advantage over competitors that rely on reactive strategies. Fourth, geopolitical risk is now a central component of supply chain management. Modern organizations must map not just logistics flows, but also regulatory and political landscapes that influence resilience. The firm's experience with export restrictions and Chinese countermeasures shows how rapidly political shifts can impact operational planning. Finally, limited capacity inevitably drives strategic decisions that shape long-term market positioning. How the company allocates its scarce manufacturing resources today will determine which customers remain loyal and which may seek alternatives tomorrow. Each allocation choice, therefore, becomes both a supply chain and a strategic business decision with lasting implications.